Welcome to mathematics class, pair of straight lines. Part 1. General equation of a pair of straight lines, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. General equation of second degree represents a pair of straight lines if and only if ABC, the following two conditions satisfy. ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0 and H square is greater than or equal to AB, G square is greater than or equal to AC, and F square is greater than or equal to BC. If these conditions satisfy, the above second degree general equation represents a pair of straight lines. Homogeneous equation of second degree, that is ax square plus 2hxy plus by square is equal to 0. It is a homogeneous equation of second degree. The powers of x and y in every term is equal to 2 or equal to 2. So then it is a homogeneous equation. This equation represents a pair of straight lines passing through the origin. Ax square plus 2hxy plus by square is equal to 0 represents the equation of a pair of straight lines passing through origin. మూల బిందువు గుండా పోయే రెండు రేఖలను సూచిస్తుంది ఈ సమఘాతీయ సమీకరణం. ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. ఒక రేఖా యుగ్మాన్ని సూచిస్తుంది. ఈ క్రింది నియమాలను పాటిస్తే అది ఒక రేఖా యుగ్మాన్ని సూచిస్తుంది. ఈ సమఘాత సమీకరణం మూల బిందువు గుండా వెళ్ళే రేఖా యుగ్మాన్ని సూచిస్తుంది. If h square is greater than or equal to AB, the two lines are real and different. If h square is equal to AB, the two lines are coincident or parallel. If h square is less than AB, the two lines are imaginary, having origin as the real point of intersection. If ax square plus 2hxy plus by square is equal to 0 represents the pair of lines y is equal to m1x and y is equal to m2x, then ax square plus 2hxy plus by square is equal to b into y minus m1x into y minus m2x. If you multiply right side and comparing the coefficients both sides, we get m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b, where m1 and m2 are the slopes of the lines represented by the pair of straight lines. Both are passing through the origin. Angle between the lines given by ax square plus 2hxy plus by square is equal to 0. Then the angle between the lines if the lines represented by the pair of straight line or y is equal to m1x, y is equal to m2x, and the acute angle theta between the lines, then cos theta is equal to a plus b by under root a minus b whole square plus 4h square. ax square to hxy plus by square రేఖా యుగ్మం చేత సూచించబడే రేఖల మధ్య కోణం θ అయితే cos θ is equal to a plus b by under root a minus b whole square plus 4h square, or tan θ is equal to m1 minus m2 by 1 plus m1 m2, or 2 root h square minus ab by a plus b. If two lines are coincident, then h square minus ab is equal to 0. If two lines are perpendicular, then a plus b is equal to 0 is the condition. లంబరేఖలు అయితే a plus b 0 అవుతుంది. సమాంతర రేఖలు లేక అయినప్పుడు h square minus ab is equal to 0 అవుతుంది. సమాంతరము లేదా కోఇన్సిడెంట్. ఒక రేఖ పైన మరొక రేఖ ఉన్నప్పుడు bisectors of the angles between the lines ax square plus 2hxy plus by square is equal to 0 is given by x square minus y square by a minus b is equal to xy by h, or if you cross multiply you will get the same, can be written in this form: h into x square minus y square minus a minus b into xy is equal to 0. Let us prove this theorem. If the angle between the straight line represented by the equation represented by the lines, pair of straight lines, ax square plus 2hxy plus by square is equal to 0 is theta, then show that cos theta is equal to a plus b by under root a minus b whole square plus 4h square. Or proof. let h is equal to ax square plus 2h xy by square is equal to L1x m1y L2x plus m2y. Then the two lines represented by the pair of straight line B L1x plus m1y L2x plus m2y. Then the lines represented by ఈ రేఖాయుగ్మం చేత సూచించే రేఖలు are L1x m1y is equal to 0, L2x m2y is equal to 0. The two lines represented by the straight line. If you multiply both lines, that will be equal to the pair of straight line. Ax square 2h xy by square. Multiplying these two right side L1x into L2x L1 L2 x into x square L1x into m2y. So L1 m2 x y multiplying with m1y L2x L2 m1 x y m1y m2y m1 m2 y square. Comparing coefficients, both sides we get x square coefficient A L1 L2 L1 L2 is equal to A and y square coefficient m1 m2 is equal to B, and XY coefficient L1 M2 L2 M1 L1 M2 L2 M1 XY coefficient గుణకాలను పోల్చితే A గుణకము L1 L2 B గుణకం X గుణకం L1 L2 that is equal to A. B గుణకం కంపేర్ చేస్తే M1 M2 is equal to B. Y square గుణకం XY గుణకం కంపేర్ చేస్తే L1 M2 plus L2 M1 is equal to 2H. Now, angle between the lines L1 X M1 Y and L2 X M2 Y. In straight line, if the angle is theta, then cos theta is equal to L1 L2 plus M1 M2 mod divided by under root A square plus B square, here L1 square plus M1 square and L2 square plus M2 square. This is the angle between two lines in straight line. If the lines are given, the two separate lines are given, then the angle between them, if A1x plus B1y, A2x plus B2y, A1 A2 plus B1 B2 by under root A1 square plus B1 square and A2 square plus B2 square. Here in place of A1 A2 we have L1 M1. In place of A2 B2 we have L2 M2. A1 B1 A2 B2 L1 M1 L2 M2. So this is the angle between two lines. Substituting L1 L2 is A and M1 M2 is B, and multiplying the denominator L1 square into L2 square L1 M2 L1 square M2 square M1 square L2 square M1 square M2 square. Numerator the required result is there. In denominator, by rearranging this L1 L2 minus M1 M2 whole square. A square plus B square is there. So A minus B whole square, A square plus B square minus 2AB. So you can add minus 2 just minus 2 L1 L2 M1 M2 plus 2 L1 L2 M1 M2. We are writing these two extra so that the result will not change. Subtracting and adding. So by rearranging the terms in denominator, this is L1 L2 minus 2 L1 L2 M1 M2 plus M1 M2 whole square. This is A square plus minus 2AB plus B square. It is almost in the form, and the other terms plus L1 M2 plus L2 L1 M2 whole square L2 M1 whole square plus 2 L1 L2 M1 M2. This is A minus B whole square, A plus B whole square. So numerator, no change. This is A minus B whole square. Here A is L1, L2, B, M1, M2 whole square. This is A plus B whole square. Here A is L1, M2, B is L2, M1 whole square. So above result comparing the coefficients L1, L2 is A, M1, M2 is B, L1, M2 plus L2, M1 is 2H. In the first step, we have compared multiplying the two lines L1, L2 is A, L1, L2, M1, M2 is B, and L1, M2, L2, M1 is 2H. Substituting these values, now we get the required cos theta is equal to mod A plus B by under root A minus B whole square. 2h whole square can be written as 2 square is 4 and h square. So this is the required result. Hence proved. Very simple theorem. Angle between the pair of straight lines ax square plus 2hxy plus by square is 0 is theta. Then show that cos theta is equal to a plus b mod a plus b by under root a minus b whole square plus 4h square. So let the two lines, pair of straight lines represented by the equation or L1x plus M1y is equal to 0, L2x plus M2y is equal to 0. Multiplying both the equations and comparing the coefficients, x square coefficient A and right side x square coefficient L1, L2. So A is equal to L1, L2. And comparing the y square coefficient left side B and right side y square coefficient M1, M2. So B is equal to M1, M2. Comparing the xy coefficient, left side two terms L1, M2 plus L2, M1. Left side 2h, xy coefficient. Therefore, 2h is equal to L1, M2 plus L2, M1. After comparing and getting the values A, B to H, then the angle between two separate lines is given by, from the straight line, L1, L2 plus M1, M2 by under root L1 square plus M1 square, L2 square plus M2 square. We know if the lines are A1x plus B1y, then A1, A2, B1, B2 by A1 square plus B1 square into A2 square plus B2 square. So we know this formula. It is there in straight line. So we are using this formula. Here, the lines are L1x instead of A1x. And instead of B1y, we have M1y. So A1, A2 in place of A1, A2, we get L1, L2. B1, B2, M1, M2. So in numerator, substituting this L1, L2, A, M1, M2, B, numerator multiplying this and adding and subtracting these two terms and rearranging them, this will become A minus B whole square and this is A plus B whole square, where in this A is L1, L2, B is M1, M2. In this A is L1, M2, B is L2, M1. And substituting this value, we get this required result. So very important theorem. Practice it. Thank you. And you can practice the other theorems from the textbook. Thank you. Thank you for watching this video.